Okay, when you do an SN2 reaction, there is another factor that it's not just all about the nucleophile. It's mostly about the nucleophile. There is also some credit that goes to sterics around the alkyl halide. But we also can talk about solvent effects. So the solvent is the medium in which the reaction occurs. The solvent brings all the reagents together so that they can mix together and have their intermolecular collisions and result in the reaction. As it turns out, when you do an SN2 reaction, so let's say methyl bromide is a simple one, and we react this with sodium azide, we need a salt or a solvent in here. And there are two categories I want to put these solvents in. There's going to be aprotic solvents, and these are solvents that have no OH, really no OH groups. And then, if there are aprotic solvents, you can imagine there are protic solvents. And protic solvents have OH groups. Now, protic solvents aren't limited to OH groups, but that's really all we encounter. So, the solvent can help or hinder this reaction where we replace bromide with azide. And let's draw the mechanism for kicks. We attack and we kick out that Br. Great. Okay, what are the good aprotic solvents? There's one called DMSO. There's another one, DMF. And those are really the main ones. DMSO stands for dimethyl sulfoxide. Looks like that. It is a classic solvent used for SN2 reactions. And DMF stands for dimethylformamide, and it looks like this. These are the two, by far, #1 SN2 solvents that people use. If you see those, I typically think there's a good chance someone's trying to do an SN2. What are the protic solvents? Protic solvents include things like water. Of course, water contains OH groups, and alcohols. So what are the alcohols? Well, I mean, R could be CH3. It could be ethyl, CH2, CH3, etc. Now, as it turns out, protic solvents are not as good for SN2 reactions, and it's because these OH groups tend to form hydrogen bonds with our anions. So if you're in water and you have azide, you're going to start to form some hydrogen bonds to your azide. Now remember, good SN2 nucleophiles are sensitive to sterics. So when you put them in a solvent, like a protic solvent, that tends to form this, what they call a strongly coordinated solvent shell around your nucleophile, all of a sudden your nucleophile is no longer lean and mean, but it's dragging along its four solvent friends with it. It's no longer mean. So this protic solvents make the nucleophile more bulky, and bulky is bad for an SN2. So protic solvents inhibit SN2 reactions. Now, when you have one of the really good nucleophiles like sodium azide, it really doesn't matter. But when you have the good nucleophile, the merely good nucleophiles, the use of protic solvents suppresses the SN2 reaction and allows other processes to come to the front, namely elimination reactions. We haven't talked about them, but protic solvents, we're going to see them tend to lean the reaction away from the SN2 reactions to other reactions of the big four. So in general, if you want to do an SN2 reaction, stick with solvents like DMSO and DMF.